Alright, I wanted to make a video class going through a popular homework type of question involving finding area under a normal curve between 2 and 3 standard deviations above the mean. So depending on how the problem is worded, they could be asking you to use a z-score chart like a table, or they could be asking you to use the empirical rule, the range rule of thumb, which again said that if you're within 1 standard deviation of the mean, 68% of all data lies there. 2 standard deviations of the mean, like this case. Do you remember what that was? That's right, 95% of all data lies between 2 standard deviations. So 2 to the left, z equals -2, 2 to the right. Which also implies that if you were to cut it in half, let's see if I can get another color here. If you were to cut that in half, because of symmetry, you would have 95 divided by 2. I don't know why I said 34. I was thinking 68, I guess. But if you cut 95% in half, say 95 divided by 2, you get 47.5. So in this little piece here, you're talking about 47.5%. And also on this left side, 47.5%. So when you add those together, that's 95%. Also with the empirical rule, we notice that if you're within 3 standard deviations of the mean, your data makes up a 99.7% area under that curve. So if you take 99.7%, and that's the entire area underneath the curve between z equals -3 and z equals +3, again, dividing that into 2 pieces so that you can get a better picture of what's happening here to the right above the mean. Oops, sorry, it doesn't look perfectly in half. If you cut that in half, what is 99.7 divided by 2? Go ahead and try that. 99.7 divided by 2, did you get 49.85%? So let me erase here. 49.85% for this right half above the mean. 49.85%. And similarly, 49.85% would be to the left or below the mean. And if you add up 49.85 plus 49.85, you should be getting 99.7. Okay, now this empirical rule is less precise. So this way of doing things, it's a great way to do it if you don't have access to a chart and you want to just get a quick idea of what the approximate likelihood would be, probability would be. So we can do the problem that way, and we'll come back and finish it in a second. But if you have access to a z-score table, this problem is a lot easier and more precise. So to begin, we're going to look up the area under a curve using our table, our z-score chart that came with our textbook here. And there's different charts depending on the textbook you have. Ours always measures area to the left. So it always gives you area to the left. Okay, so let's take a look at how this would be. Now, if it's telling you between 2 and 3 standard deviations above the mean, remember that above the mean it means to the right. This means to the right of the center. So if the center is in the middle of the bell curve, it's normal, so it's bell-shaped. If you put your mean in the center, above the mean would be to the right. So I went 2 standard deviations to the right. This would be z equals 2.00. And I would look that up under the positive z-score. Because it's to the right, above, you have to look at the positive z-score. Now when I look up my chart, I'll start by going down to 2.0 and then over to 0.00. And when I do that, I'm getting 0.9772. So my table, if you will, here is telling me 0.9772 is the area to the left. It always tells you the area to the left in the table of that z-score, which means as a percentage, it's the same thing as saying 97.72% of all values are below that z-score. Okay, now let's look at 3 standard deviations above the mean. Well, that's going to be, again, above, meaning to the right of the mean, 1, 2, 3. So positive 3.00 is my z-score that I look up in my table. And when I do that carefully, looking up 3.00, I should be getting 0.9987. Is that what you got? Check it out. 0.9987, which is, as a percentage, 99.87% likelihood. So now we found the likelihood of being below, the likelihood of being below here is 9772. The likelihood of being below here is 9987. Now notice what they ask us though, okay? They want to know what is the likelihood of being between 2 and 3 standard deviations. So if this is the 2 marker, that would also be the 2 marker here, wouldn't it, in my chart? So we're saying between 2 and 3. We're really looking for this region, aren't we? So we're saying the probability that Z is between 2 and 3, so Z is greater than 2 but less than 3, would be the larger area, which is 0.9987. So you're basically taking this larger area and subtracting the smaller area, which was 0.9772. That was this space. So when you take that larger area minus the smaller area, you'd get the area in question. So that's what we need to do here. We need to actually take as decimals 0.9987, and we need to subtract, since it's between, we're going to subtract the larger minus the smaller area, minus 0.9772. Oops, that's a 7. 9772. And when you do that, you can do it by hand. 7 minus 2 is 5. 8 minus 7 is 1. 9 minus 7 is 2. And 9 minus 9 is 0. So this is the more precise answer, the more precise way of doing things using the table. We're getting an answer of very small likelihood that you're between these two z-scores, between 2 and 3 standard deviations above the mean. As a percentage, moving that decimal 2 places to the right, you're looking at a very small likelihood, 2.15%. Again, this is the preferred answer when you have access to a z-scored chart, a table, like our ebook does, as well as if you have access to technology like a graphing utility, it can give you a more precise answer. If, on the other hand, you did not have this chart and you needed to do it with the empirical rule, again, feel free to stop the video if you want to just know one way right now. That's fine, if that's all your homework asks of you. But if you wanted to know how to do it using the empirical rule here, you would notice that to be 2 standard deviations above the mean is here, z equals 2. But the empirical rule talks about between 2 standard deviations. So that was 95% of all, we had to memorize that. 95% of all values lie within 2 standard deviations of the mean. So that meant, cutting that in half, I got 47.5 on each side, left and right, so below and above. So the part that we're more interested here is above the mean. Okay, so we're looking here. And we're going to hold on to that information. Then we look at 3 standard deviations above the mean. The empirical rule says that 99.7% of all data lie within 3 standard deviations of the mean. So we cut that in half to get to the left and the right and got 49.85% above and below the mean there. So what we're really asking for again is between z equals 2, which is here, and z equals 3. So once again, we're really interested in this between business here. So how could we do that pretty easily? Well, we could almost ignore the left side, couldn't we? Because if I want to just find this little piece, I really don't need to talk about what's happening below. So I would simply want to subtract the larger green area minus the smaller blue area. So as percentages, I could say this would be found, this answer here, by taking 49.85% and subtracting the blue smaller region here, 47.5%. Again, I'm working in percents this time, 0.50. And then the percentage answer that I'd be looking at, you can do it by hand or in your calculator. 5 minus 0 is 5. 8 minus 5 is 3. 9 minus 7 is 2. And 4 minus 4 is 0. So I'm looking, when I don't go as precisely, when I look just at the empirical rule or the range rule of thumb, I'm getting 2.35% likelihood. So it's not quite as accurate as the chart here, 2.15%, or as a decimal, 0.0235. Okay, so not quite as accurate as 0.0215, but it gives you a good starting place if you did not have access to technology or to a Z chart. Well, I hope this has been helpful for you. Keep in mind, between always will mean you'll need to subtract the larger area minus the smaller, and above the mean meant to go to the right, and also that if you are above the mean, your Z-score is positive, not negative. I hope this was helpful. If you have any questions, please feel free to reach out to me. Otherwise, happy practicing, and remember, math is not a spectator sport. I'll see you next time.